replace what today's are centralized services. Okay? So one of the most fundamental or core service is the service to find other people, in order for me to find you, or you. And once I find you, then I have to get connected. Okay? So after a lot of thinking and a lot of evolution on this, we end up with a solution that we call the Internet of People. What is the Internet of People? At the conceptual level, it's like a data structure, a graph, a mathematical graph, with let's say a social graph, because each node of the graph represents one profile, and each edge is a relationship between the profile. Okay? So I think that you can imagine what I'm talking about. If not, I put it in more simple terms. It's like if you take Facebook user-based database and combine it with Google database and combine it with LinkedIn and combine it with all databases and put it like in a blockchain-like structure that is public and open and everybody can use. Okay? So instead of going to Facebook to ask permission to see which are my contacts, we put everything there that is public, that people want to put public, and then is, as the blockchain, anybody can read this structure, and anybody can use this structure for finding people and connecting to each other. So conceptually, this data structure that is not a blockchain. It's important to understand that it's not a blockchain per se. It uses it has some similarities in the sense that the blockchain can be defined also as a data structure that is cryptographically secure. Okay? When you put transactions in blocks and you link one block to the other and you start hashing it like in a chain, then you have a way to secure this cryptographically. Okay? But that is good for a transactional system, okay? Where you are recording a log of transactions. So it makes sense to package this batch of transactions in blocks and create this structure that is called like a chain. But if what you want to store is not transaction, but people's profiles and the relationship between the profiles, it doesn't really make a lot of sense to pack it in block and chain. At least it doesn't make sense to me, no? So because it's not the same problem, it's a different problem. So the structure here is a graph, but it's also a cryptographically secure graph in the sense that each node of the graph is a profile, a set of information that I upload voluntarily to whatever this is running, okay, and I control it with my private key, meaning that I am the one that can change it and modify it, okay? And it's also linked between each other with these edges of the graph. That is also a data structure that is signed, in most of the cases, by the entities that are connected by that edge. Okay? So, to say in an example, if we are friends, or I'm your student, then you sign me a data structure that verifies that I'm a student, and also that you allow me to make this public. Okay? Once I have this signed by you private key, I can put it, and this might be this now. Okay? I connect my profile to you, representing that I am a student of you. Okay? And because it's signed by you, then this has this similarity to the blockchain. Instead of being blockchain, it's also secured by public and private key cryptography, but with this kind. Okay? So conceptually is this. So, which type of relationship is support? Well, in Facebook you can be friends with people, maybe you can be close friends or some variation of that. In LinkedIn you are colleagues and this and that. Here you can be almost about anything, because for the data structure it doesn't matter. In fact, it's the job of the consortium to define the different type of relationship and the different type of profile. And the system is open for any type of application. That means that it can be used by chat application, by taxi application, by dating application, by whatever you can imagine, can upload their profile here and start linking profile between each other as they wish. Okay? Okay, so this is at the very conceptual level. Well, these links, the edges of the graph, broadly. No? There are links that are public. As I explained, I'm your student and nobody cares if this is known. So you authorize me to be a public link. And, or it can be something that I want to keep private. My son, my daughter, or who knows. No? So there are private links and public links. So if you see the graph is, I'm still not talking about how this is implemented, exactly. But I am going to that direction now. We need to have this graph that is public, like a blockchain, anybody can use it. Anybody can innovate on this. But some of the links are private. So where is the best place to keep the private links? Well, in our view, all this structure, data structure, is distributed on a peer-to-peer network. Okay? In public peer-to-peer. Imagine the Bitcoin blockchain, but instead of transaction, it's this stuff. Instead of being blocked, they are putting this way. Peer-to-peer network, anybody can use it. But the private links, the part of the graph that is private, okay? Each one keeps that part in their own device. Okay? So I keep my own links in my device, keep your links in your device. So the complete graph is distributed everywhere. But one part is 100% public, the other part is private. And if you want to know my contacts, you have to come and ask for permission. Or I can voluntarily show you for some specific cases. For example, if I want to make a very big transaction with you, and I want to prove that, as you can see, some people have many different profiles, okay? Because they are profiled by different applications. They might be linking between each other. But let's say I am in this situation, that I have 3 profiles that are interconnected publicly, and one that is isolated, because I don't want to make public that is also me, okay? But I can prove you privately that this is also me if I want to have more reputation, for example, so that we can make a bigger business, things like that. No? So far we have that all this structure is run on a public peer-to-peer network, except for the private links that are kept in individual devices. How is this connected then, one thing to the other? Well, we take this like one step further, and what we said is, let's allow these devices to have an open connection to the peer-to-peer network, where if I find him in the network, let's say it's this one, I find him, then I find the node on the network, the server on the network where his profile is hosted, and at that node, his phone has an open connection. Okay? This is very important because if he has an open connection, then I can initiate the process to establish a communication with him that could end up in a direct phone-to-phone communication. Okay? So first, I find you for whatever means, by geolocation, by name, because you're a student, you have a student profile. It can be hundreds or thousands of ways to find you. But once I find you, and I find where your profile is hosted in the network, I also find your connection. So I start with the help of what we call the profile server. With the help of the profile server, we start the process of signaling to agree where or how we are going to acquire that direct connection if possible. Okay? If we manage to get the direct connection, then we forget about all this, and we start communicating directly for whatever business we have to do. It can be social stuff, it can be a business, or it can be whatever. Okay? Because in my phone, I am supposed to have a set of applications that understand all this, and you may have some of these applications, and the applications that are in my phone and your phone, they can speak together through this direct connection, and we are totally disconnected from the rest of the